Hello, everyone, and welcome back. My name is Mr. Cobalt, and in this video, I'm going to be going over how to calculate and figure out what the K value of your target equation is based on the K values of other equations that might have a relationship to the one that you are figuring out. So let's get into this. So, again, in order to figure out what the missing K value is, you need to figure out like how the equations you are given relate to your target equation. So, for example, here in this, sorry about that. So, in this example here, we are given this is our target. This is the one equation that we're trying to find the equilibrium constant for. And we're given these two to work with. And they give us the K values for these two. So we got to figure out how these two are related to this one. And so the three things we need to remember is that if you have to reverse a reaction, then when you reverse that reaction to get the new reaction, then the K for the new reaction is the inverse of the old one you reversed. The second thing you have to remember is that if you multiply your equation by a factor, then you need to raise the original K value to the power of that same factor. So if I multiply my equation by 2, then the K value of my new equation is going to be the K value of the other one raised to the power of 2. And finally, the third thing is that if you add equations together to get the equation that you want, then what you need to do to the K values of those equations you added is multiply them together to get the to get the K value of the new equation. Okay, so let's get started on this. So here's my target equation, and I have these two to work with. So I want to make sure that all of the things on this side are matched with what I have here as a products and reactants. So you'll notice here that I have CH3OH and water as products. So I want those to be on product side. So notice here that I have CH3OH as a product, and so that matches with what I have here. So I don't need to reverse this reaction. I want to keep it the way it's written. Now, what about water and hydrogen and carbon dioxide? So here you'll notice that I have water. This is the only equation I have water in, and it's on the reactant side, but I want water on the product side. Also, you'll notice I have CO2 and H2 here as reactants, but here I have them as products. So this reaction here, I'm going to have to reverse. So I'm going to rewrite it here in the reverse direction. So I'm going to have CO2 gas plus H2 gas in equilibrium with CO gas plus H2O gas. So now that I have my water on the right side here, and I have my hydrogen and carbon dioxide on the left, where the reactants are, now all I need to do is figure out what the new K value is. So for this reaction, we'll call this K4. So K4 is going to be equal to K2, except it's going to be the reciprocal of K2. And so that means that it's going to be equal to 1 over K2. So 1.0 times 10 to the 5th. And then I can calculate that. And so let's calculate that out right now. So here I have 1.0 times 10 to the 5th, and I take the reciprocal, 1.0 times 10 to the 5th, and then I take the reciprocal of that, and I get 1.0 times 10 to the negative 5th, which makes sense because when you bring this up to the top, then you change the sign of your exponent. So now I have the k value for my new equation here. So we don't need this one anymore. So I'm going to cross this out to prevent any confusion. And so now we have these two to work with. So look, now the next thing you want to do is look at the coefficients. Are the coefficients the same as you would need them to be in these equations? Are they the same here? So I have CO2 with a 1. I have CO2 with a 1. I have over here water with a 1. I have water with a 1. Here I have CH2, but it's only got 1 there. But notice I have 2 here. So these 2 plus this one gives me 3. So I have 3. Excellent. Now the thing that you notice here, that I have CO here, but I don't have CO in my target equation. That means that CO should cancel out. And so if I look, here I have CO as a reactant, so I need it as a product, and that's what I see here. So CO cancels out. So everything looks good. All I need to do is add these together. So I'm going to add these together. And so when I do, the CO here and the CO there cancels out. And then I have the CO2. So my CO2 plus my 3 H2 gases, that's in equilibrium with my CH3OH gas, plus, and then I have my H2O gas. So it's clear that adding these two equations together gives me my resulting equation. And as I said in the beginning of the video, is if you add equations together to get the resulting equation you want, then you need to multiply the k values of those two equations, or whatever number of equations you have to add together. So since I added these two together, that means I need to multiply. Did I say add the k values? No, don't add the k values. You multiply the k values together. So I don't know if I said add. If I did, that was a mistake. I meant multiply. So I'm going to multiply K3 and K4 together. So my K1 is then equal to K3 multiplied by K4. And so that becomes 1.4 times 10 to the negative 5 multiplied by 1.0 times 10 to, not negative 5. What am I doing? 7. So got a power of 7 there, 7. And then this is negative 5. So when I multiply these two together, I get 1.4. When I multiply these together, I'm adding the coefficients. So 7 minus 5 gives me a 2. So that, ladies and gentlemen, is the k value, the equilibrium constant for my resulting equation. That is it. That's how it's done, ladies and gentlemen. Thanks for joining me. I hope you enjoyed this video. If you did, if you learned from this video, if this helped you in any way, then please, by all means, like the video, share the video with your friends, hit that like button. Also, make sure you subscribe to my channel. And when you do, click the notification bell. And when you do that, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.